Hey guys, welcome back. So what we're looking at today is 5.5 claims and conjectures. Let's go ahead and jump right in. So we're looking at a couple things within the lesson here, just definition wise and just so you can kind of understand what they are. So this is vertical angles. So when two lines intersect, the opposite angles formed at the point of intersection are called vertical angles. In the diagram below, angles 1 and 3 form a pair of vertical angles, and 2 and 4 form another pair of vertical angles. So we're not going to take and examine the tessellation or anything like that, but what you need to know about vertical angles, they are across from each other. So 1 and 3, they're right across from each other when these intersect, and they are congruent. So they're going to be the exact same angle measure. So we're 2 and 4. So when you have vertical angles, this is something you'll use in proofs. When we have intersecting lines like this, you can say that angle 1 and angle 3 are congruent because the definition of vertical angles. Exterior angles of a triangle. So when a side of a triangle is extended, as we can see here, this side has been extended, the angle formed on the exterior of the angle is called an exterior angle. The two angles of the triangle that are not adjacent means next to, so angle 3 would be the adjacent angle. So that are not adjacent to the exterior angle are referred to as the remote interior angles. So remote islands are far away and isolated. They're by themselves. They're distant. So you can use that to kind of help you think about these two are the furthest away from the angle on the outside. In the diagram, angle 4 is an exterior angle, and 1 and 2 are the two remote interior angles. So what this means is the measure of an exterior angle, so the measure of angle 4, is the sum of the measures of the two interior angles. So in this case, angle 4 equals angle 1 plus angle 2 every single time. So if you have these two angles, add them together, it's going to give you the one on the outside. If you need to solve, set this angle, the exterior, equal to the two inside. Equal to the sum of the two inside, I should say. All right, and the last thing you need to know about is parallel lines cut by a transversal. So when a line intersects two or more other lines, the line is called a transversal line. So that's this diagonal line right here. Now, it does not have to be diagonal, but it is in this case. When the other lines are parallel to each other, some special angle relationships are formed. To identify these relationships, we give names to particular pairs of angles formed when lines are crossed or cut by a transversal. In the diagram below, angle 1 and 5, their corresponding angles are in the same relative position. 3 and 7 are corresponding, 2 and 6, 4 and 8. Those are all corresponding angles. Angles 3 and 6 are alternate interior angles, so are 4 and 5. So they're on opposite sides of the transversal, and they're in between the two parallel lines, so alternate interior angles. And 3 and 5 are same side interior. So once again, they're in the interior between the two parallel lines, but they're on the same side. Now, in this case, same side interior angles are going to be supplementary, whereas alternate interior angles will be congruent, so will corresponding angles. Also, we have the same rules for interior as we do for exterior. So 1 and 7 are exterior angles. They're same side exterior, so they'd be supplementary. So when the transversal line intersects two parallel lines, corresponding angles are formed are congruent. Alternate interior angles formed are congruent. Same side interior angles are supplementary. Same side exterior are supplementary. And alternate exterior are supplementary. So just a few things there that will help you later. All right, so on to the actual ready, set, go. So what we have here is properties of quadrilaterals. Use what you know about the triangles to write a paragraph proof that proves that the sum of the angles in the quadrilateral is 360 degrees. So I'm going to have you guys do this. I want to see what you can come up with for this. So use what you know about triangles. Think about splitting your quadrilateral in half and explaining what you know to show how it'd be 360 degrees. Now, the angles in a quadrilateral do all add up to 360 degrees. So for number 2, we're going to take 4x plus 23 plus 16x plus 15 plus 7x minus 3 plus 6x minus 5 and set it equal to 360. So we combine like terms. So we've got 4x plus 16 plus 7 plus 6, which is going to give us 33x. Then we look at our constants. So we have 23 plus 15 minus 3 minus 5, which is going to give us 30 equals 360. Now we solve. We're just solving for x. So minus 30 minus 30. So 360 minus 30 is going to give us 330. Divide by 33. So 330 divided by 33 is going to equal 10. So x equals 10. And then we'd be able to plug that back in and find each of the individual angles then. Okay? So this is your answer. Match the equation with the correct line in the graph of the lines P, Q, R, and S. So number 3, we have y equals 3/4 x plus 2. So we know it has a y-intercept of positive 2. So we're going to go here. Here's our positive 2. Now there are 2 lines that intersect at this point. So we need to figure out which one has a positive 3/4 slope. Well, a positive slope is going to go up 1, 2, 3, and to the right 1, 2, 3, 4. So it is S. So that's what you're going to do. So same thing, number 6, you've got y equals negative 3/4 x plus 4. So that means you're going to go up here to the 4 on the y-axis. Once again, there are 2 lines, both positive and negative slopes. This one has a negative 3/4 slope. So down 1, 2, 3, over 1, 2, 3, 4. So it is P for this one. All right. The next section is looking at our parallel lines cut by the transversal. So all those conjectures that we had, your keyword is conjectures, about the parallel lines, the vertical angles, and the exterior angle. So we're taking and saying what each picture represents. So on 8, what kind of angles, what does this represent? Well, it's intersecting lines, so it's vertical angles. Now, what about number 9? So notice parallel line cut by the diagonal. So we have parallel lines, and I'm abbreviating. I'm not going to write the whole thing out. Parallel lines. We also have intersecting. So we've got that angle there, and that angle there would be the same. This one and this one would be the same. We've got vertical angles going on in there. And look, we have a triangle formed right here with an extended side. So we have an exterior angle of a triangle too. So I'm just going to say exterior angle. So that's what you're looking at here, is trying to figure out what of those postulates can be represented by these different real life pictures and so forth. So some of them will have all 3, others will have just 1, they may have 2. So just kind of depends on the picture. All right. The next section, find the value of the 2 remote interior angles in the figures below. So the one we're looking at here is 17. So the exterior angle is 120. So I'm going to write this up here. And remember, we add the 2 remote interiors together. So 2x plus 10 plus 6x minus 10. So 10 minus 10, that just goes away. 6 plus 2 is going to give us 8x equals 120. And so then we divide. So we take 120 divided by 8, and we're going to get 15. So x equals 15. So then we have to actually plug that in these. So 2 times 15 is going to give us 30, plus 10 will give us 40. So this angle here is 40. And for this one, we'll do 6 times 15 minus 10, which will give us 80 degrees. And 80 plus 40 does equal 120. So we have it right. Okay, so that's what you guys are doing. So make sure you find the actual angles and not just what x equals, okay? So same idea for 18 and 19. All right, now we're looking at our next conjecture, our parallel lines cut by a transversal. So number 20, we have 5 and 8. These are across from each other. What kind of angles are across from each other? Vertical ones, and they are congruent. All right. Next one we're looking at is 22, 2 and 8. 2 and 8 are on the same side in the exterior, so they are supplementary. Anytime you have them on the same side, they're going to be supplementary unless they're corresponding. So if they're exterior or interior, then they are supplementary. If they are on opposite, so one's interior, one's exterior, then they are congruent. All right, and the last one, 3 and 5. So 3 and 5 are also on the same side, and they are in the interior, so they are also supplementary. All right, and the last section, complementary and supplementary angles. Find the complement and supplement of the given angles. It is possible for the complement or supplement not to exist. So 37, if we take 90 minus 37, we're going to get 53. So its complement is 53 degrees. Its supplement, we'd take 180 minus 37, which is going to give us 143. We're just finding what it takes to complete having the complementary or supplementary angles. All right, if you guys have any questions, feel free to ask. Have a great day. Bye, guys.